So, good morning everyone. My name is James Riley. I'm the Health, Safety and Environmental Director for Strabag UK. Today we're here at the Lockwood Beck site for the Wilton Mine.
We're here on site to create a shaft down to the tunnel level to provide services for that TBM to continue beyond us and towards the final destination, towards Whitby. Here at Lockwood Beck we create a 3.2 metre diameter shaft, and we'll be installing ventilation along with other services that allow the TBM to continue driving.
We brought in a company from America who specialises in these deep shafts, and it's a different culture for them, and bringing it into the UK with all their different types of legislation, their different equipment that they have to use here, the actual guarding of machinery, all our procedures. This task has been very comprehensive, and the company have been fantastic in coming on board, looking at our systems, working with us from day one, putting the systems into place and adopting our culture.
Today is normal maintenance shift. We already started cleaning, and then we'll restart in the afternoon as soon as we have completed the weekly maintenance. And that's all from our side.
So for Lockwood Beck, there's no new COVID cases to report today. And for production, yesterday day shift, the team drilled 5.8 metres, and on night shift drilled 7 metres, bringing us to a total depth of 362.1 metres. So we have now gone beyond the crown of the tunnel. We're around about the tunnel axis level. There's nothing to report in terms of increased water losses or weight on the bit, etc. So everything appears to be okay from our end, and obviously we'll keep in touch throughout the day.
Everybody, have a nice day, and here's tomorrow.
You all have fun. The mandatory PPE is a high-vis top and trousers, hard hat, gloves, glasses and boots. Anytime you go through those turnstiles, that's the expectation, and that's what we require you to wear to be able to work on the project. So before we go on to site, the requirements to go on to the project is that you've scanned into Zone 7 in the morning, and it's just to show the system, the mosaic system, that we've got the people on site, and then to be able to access from what we call Zone 7 to Zone 8, which is the construction project, we have to go through a start shift briefing. There's a briefing delivered on the production requirements for the day, any health and safety notifications, any visitors, and just things to expect through the shift really. So the card you've got, that'll be scanned, and then you'll be granted access onto the site.
So you can see behind us here, this is the reaming operation for Lockwood Beck. It's a blind boring reaming rig, a very specialist piece of equipment that has been manufactured and enhanced over many years by Shaft Drillers International. We're around 361 metres deep, currently at the axis of the tunnel level, nearing the end of the drilling operation. You can't see what's going on down at the bottom of the hole. All of the workforce is stood on surface. The hole itself is full of water, and the reaming head is cutting down at a lower level, similar to the TBM. So it has cutting teeth, it rotates onto the rock, breaking and fracturing, and then through a reverse circulation with the use of air pressure, the cuttings are brought up through the centre of the pipe. They're fed over into the site lagoon that we have. At that point we take out the bulk of the cuttings. The water then recirculates around the process with a fine drop into the bottom, keeping the water clean and light. It's then brought back through a 12-inch pump and fed back into the shaft and taken to the bottom and repeated. So it's a constant 24/7 operation where the drilling head creates the cuttings, they're brought to surface where they're dealt with, and the reaming continues. There's a lot of phases to the drilling operation. Whilst we're looking at currently the reaming process, unlike the TBM, we're not provided with a finished article at the end of it. So there's a number of phases. The first thing we have to do is a pre-grouting operation. So working around the circumference of the shaft, we create a more sound body of ground. It doesn't need to be watertight, but it needs to be able to withstand and capable of holding that water so that we don't lose it during the operation. So if the water was dispersed into the ground around it, then the operation wouldn't be able to continue. And then on to the reaming. So the reaming schedule is 80 days. We're currently looking at a completion within 50 days. So we're doing very well. We've had challenges along the way where we've had to trip out and repair sections of the ground due to a minor collapse. So at that point we had to fill the shaft back up with aggregate, create a grout plug to improve the ground in that zone, and then restart the drilling down to full depth. Once that's complete, we have to install the casings. The ground is held out by only water, and then we install these casings one by one. Once they're in, after around a 40-day program, we grout the annulus, and then it's job done. We'll just have a look at one of the casings. So there's 43 number of these steel cans that are used to create a permanent lining within the shaft. The casings themselves vary between 15 and 30 millimeter thick steel plate. They're rolled, welded and coated here locally on site. The casings themselves, you can see, have an increased number of stiffeners on the outside. The further down you go, the thicker the steel plate and the more stiffeners because of the increased ground pressures, and that reduces as we come to surface. So these casings will be installed into the shaft one by one, hung over the top of the shaft, welded, then lowered 9 meters, and the process is repeated. There's water that will be installed within the casing to allow it to sink down to the bottom. It's a controlled way of installing the casing down to the shaft depth. So it's ran through a buoyancy program. We're hoping that the drilling operation will be completed by this weekend. A couple of days to bring out the drill strings and the drilling equipment, change the platform slightly to prepare ourselves for the welding. And we're hoping the first casing will be welded and installed on Tuesday next week. The program is just over 1 day per casing. So we've got a 46-day program that we're looking to minimize as much as possible. The whole time that we're installing these casings, the shaft is open. It's open to the elements, and there's always potential of some of the ground starting to fall into the hole. So the shortest time possible for the welding program, the better. There's been a number of considerations made, obviously, before we get to this point. So we've been assessing the quality of the drilling, the quality of the parameters that we're getting back, and the amount of fallout that's landing on top of the reaming head down the bottom. It provides us an indication of how much ground may fall in, and obviously therefore how much further we need to drill the hole to allow some caving whilst the casings are being installed. Beyond the fence line, you need to complete a short induction from the drilling team to understand what risks we're being faced with today. And then beyond here, there are moving plants. So beyond the barrier, we've got a dumper which is collecting the cuttings. The crane is fenced off over the far side. As I mentioned, it will be lifting the drill strings. So beyond this point, we need to listen to the advice from the supervisors who manage this area. Within the holding area, the supervisor will provide the briefing to the workforce. We record on there the key hazards and the control measures that we've got in place. Any upcoming deliveries, the weather, etc. for the day is all recorded on the board. Any visitors that then come in can see what's being discussed and be aware of what's happening on site. And then for documentation, we have the relevant permits, the relevant RAMs, everything's available here on this station. And then we have the eye wash and the first aid kit if it's needed. So you can see behind us now how the operation actually works. So that on the drill string itself onto the gutter head, the weight is supplied by some Kentledge blocks that were installed before it went down the hole. That weight on the bit provides the force to cut, and then compressed air turns the turntable on surface, in turn spins the Kelly bar and provides the rotation. So with the weight of the actual cutter heads and the drill strings and the rotation from the turntable, that's where we get the cutting motion to break the rock. And then the cuttings, they get sucked up the central section of the drill pipe, up through the Kelly, into the overflow, and then they fall down into the cuttings lagoon. The main cuttings come through the overflow. They're pumped around at 3,000 gallons a minute into the main pit, where there's the baffle wall and the water overflows. The larger cuttings are then taken out by the attendant excavator, where they're loaded away. The water then travels around the lagoon, which is around 12,000 cubic meters, through the full system, and then the 12-inch pump at the other side then recirculates it back to the shaft.
But 123 Choose Safety was actually developed by a gentleman and his team in Germany. A gentleman was called Dr. Gunther Voss. Actually retired. He retired this year. But one of his legacies, he wanted to introduce into Strabag a group system, something that the whole group could adopt. And this is why he actually chose 1, 2, 3, because it doesn't matter what language you speak, you can understand 1, 2, 3, and the stop, think and act just works so well. It's all about information. By talking to the guys, understanding what their needs, their expectations are, we can actually try to meet those expectations. And by working as a team, we'll get better safety, better production, and that's what it's all about.
It kind of does what it says on the tin. Everyone's responsible for their own health and safety at the end of the day, and if we can kind of instill that into people, that as you go to work on a daily basis and as you're carrying out your activity, as things change around you, if you can just kind of stop, think and act at that precise moment, then the chances are that you're going to continue your day in a perfectly safe manner and essentially make it back home to your family at the end of the day.
Right, so that's the Lockwood Beck site. We've managed to walk around and see the different processes that are in operation here. I'd like to say thanks so much to Callum and to Morgan. I think this has actually shown how leadership has taken advantage of 1, 2, 3 and the way they are adopting the 1, 2, 3 initiative and our behavioural and safety systems. And that is the big thing that I really want to point out. Safety should not hinder the work we do. Safety is not here to put obstacles and hurdles in our way. Safety is here to actually make sure that we're safe and we produce our products safely and on time to target and to budget.
How have they managed to pull that out?
Well, that's too large to be a cutting coming out of the cuttings lagoon. I think what it's probably been is when they've been trimming the tools out, on the back of the cutter head is actually a flat surface because it's a hemispherical dome. So as they pull it back out, if there's any fallout from the ground from the walls of the shaft, that comes out on the top of the bit essentially. And there's been quite a few of them that we found.